Welcome everyone to another episode of West Explains Best. We're finishing up section 5.3. This is the special factoring. Here we have difference of cubes. This one gives a lot of problems to students. It's not that bad once you understand it, but let's go ahead and kind of break this down into kind of smaller steps for everyone. The first thing is, with difference of cubes, we recognize that we have a first term and a last term. Look, what color should I use? I'll use green. Okay. So that's the first thing. These both have to be cubes of some kind. Now, keep in mind, it's not always going to have the 3 there. For example, 8 is a cube. 8 could be rewritten as 2 cubed. Okay, they're the same thing. So both of these would be good in terms of being a cube, in terms of being able to factor it into this method. Okay. Next up, what we have to do is we have to find the cubed root of both those terms. Okay, so let me remind you, this is the first term, and we'll just call this the second term. I forgot to write term. Dang. Okay, so the next thing we have to do is we have to take the cubed root of the first term, and we have to take the cube root of the second term. Now, what are we going to do with that? Well, we're going to take that cubed root, and that's going to be like our building block that we're going to use. Okay? We're going to put that, let me erase this. We're going to put these things in special slots in these parentheses, okay? Now, it's going to seem abstract, like, what the heck are we doing at first? And then once we follow it all out, you kind of see why we're doing it. Okay, and we're going to go here, and then we're going to go here, and that should be it. And then we're going to go green here, and then green here, and then green here. Okay, this is how it works. We're going to put the cubed root of this first term in these blue slots. Then we're going to take the cube root of the green term, the second term, and we'll put it in the green slots. Okay. So let's go ahead and do that. We're going to take the cubed root of x cubed. The reason why we need cubes is we need it to be in a rational number. In this case, it's going to be x. X is going to be the cube root of the first term. So this is our building block. And then we're going to take the cube root of the second term, and that's going to be y. Again, it has to be a perfect cube in order for us to do this. What do we do with this? Well, we're going to put this x here. We're going to put this y here, okay? And it was said it was a difference of cubes, so it has to be a subtraction sign in between, okay? Difference of cubes means we're putting a subtraction sign in this first parenthesis. Okay, now this is the part where it gets a little funky. We're going to take the x, the cube root of our first term, and we're going to square it. And then we're going to add the first term cubed, the cube root of the first term times the cube root of the second term. And then we're going to take the cube root of the last term, and we're also going to square this guy. And then we're going to add him also. Okay, so this is our general form. And if you wanted, you could replace this first term and put it here, put it there, so that you know whatever that first term is, you're going to be putting it into those slots, and you just have to make sure to square it here, make sure to square it here, multiply it by xy here. Okay, and then the same thing with the second term. You're going to put the second term there after you cube root it, and put that squared here, and then multiply it by the first cube root there. Okay, so it makes more sense when we get to some examples. So let's go ahead and do this first one. Here we recognize that we have m cubed. It's definitely a perfect cube, so we can take the cube root of that. We just talked about 8 being a perfect cube. We could rewrite that as 2 cubed if we wanted. And some people like to do that. Some people like to go, okay, this is m cubed minus 2 cubed. Okay. Essentially what they did there is they took the cube root of the second term and they got 2. Of course, when you take the cube root of the first term, you get m. Okay. So now we're going to get our brackets ready, or sorry, parentheses ready. This one needs to be a little bit bigger. Okay, and again, what we're doing here is we're just putting m everywhere we have one of these blue lines. and we're putting the cube root of 8, which is 2, anywhere we have these green ones. So again, we're going to put, I'm going to make it dark blue this time, m, and then this is m, and then this is m. Keep in mind that this m needs to be squared. All right, then we're going to go ahead and move on to 2. So we're going to put 2, we're going to put 2, and we're going to put 2. Keep in mind that this 2, this second 2, needs to be squared. Now for the signs. The first one's minus if this is minus, okay? It needs to match this one. And then whatever is in this one, okay, we got to change these ones to positive. This guy is always positive, okay? These two might change. I'm going to talk about that once we get to sum of cubes. Let's simplify this. We have m minus 2 times m squared plus 2m, usually put the coefficient first, plus 4, and then that's going to be our final answer. Now you're like, okay, what? We just learned this crazy formula, and now you expect me to just take your word that this is going to work out to a difference of cubes, and this is the factored form. We can FOIL it, okay? We can distribute there, and we can distribute, let's go with this dark red, here, and I can show you that these will give us, once we're done, they're combined to give us what we're looking for. So we get m times m squared, m cubed, plus 2m squared, plus 4m, and that was the orange. Now we're moving on to the dark red. Negative 2m squared, minus 4m, and then minus 8. What happens here? Where we have like terms here, and then here and here. And they all cancel out, leaving us just m cubed minus 8. So it's kind of cool, I think, that differences of cubes works out so well. It's by design, and there we have it. Whoops. All right, we have it right here. Let me, there we go. It's this one, okay? All right, now, here's our next one. We have our first term here. It's all of this. Then we have our second term here. It's all of that. So we have to take the square, or the cube root of 27x cubed, and we have to take the cube root of 8y cubed. What happens when we take the cube root here? We take the cube root, we get 3, 27 cube root is 3, and then the cube root of x cubed is x. Okay, so this is going to be our first building block. Then we have cube root of 3. Cube root of 8 is 2. Cube root of y cubed is 2y. Okay, so these are our building blocks. We're going to put those into our parentheses. So we have here, 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 and then here. I'm not going to put the highlight this time. Hopefully you'll follow along. We have 3x, 3x, 3x. Okay, I'm going to go ahead and put 2y, 2y, times 2y. Don't forget your squares. This needs to be squared, so we square the whole thing in parentheses. We square the whole thing. This needs to be minus because this is minus here, and then these two are both plus. Now we simplify, okay? This, if you can do this, you can do difference of cubes. And the main thing is being able to take the cube root and then just plug them in where they go from the formula. We have 3x minus 2y, that stays the same. 3x squared, this becomes 9x squared, plus, multiply the coefficients, you get 6xy, plus 4y squared. There you go. There's your answer for the difference of cubes. This is factored form now. Sum of cubes, almost the same thing. It's the same principle. We still need to do the same thing with the square roots, etc. This time, though, the signs change slightly. So it's the same process. We're going to have x. Sorry, let me go ahead and write all the x's. X and then x. We're going to have our y, y, y. We need to make sure that these ones are squared. And then this is sum of cubes, so we need to add here. This one's always positive. I said that. In front of that y squared, it's always positive. This x squared is always positive also. But this needs to be minus, okay? So like up here, we had minus plus. For difference of squares, this one's plus minus for difference of cubes. This is plus minus for sum of cubes. Okay. Now, first glance, we see a plus sign, and we're like, huh, okay, we might be thinking sum of cubes. But then we notice here that this is not a perfect cube. 3 is not a perfect cube, and neither is 192. So we have a little bit of an issue there. But the dead giveaway that we should at least consider sum of cubes is this x cubed here. Now, what do we do with that? Well, we have to explore all options first. So what we want to do is we want to say, okay, maybe if we factor out a 3, maybe we'll have a cube root. So we're going to take out the 3 because 192 is divisible by 3 and so is 3. So we take out the 3 and we get x cubed plus 64. Okay, now we can look at this a little bit easier. We know this is definitely a perfect cube root. We don't have to worry about the 3 anymore. And 64 is a perfect cube also. 4 times 4 times 4 is 64. So guess what? We can leave the 3 out in front. And then we're going to put our parentheses because we're ready to roll with sum of cubes. Okay? So what are we going to put? Well, I already said we're going to take the cube root of this x first, x cubed, and we get x. We're going to take the cube root of 64. We're going to get 4. Okay, so anywhere we're going to put for the first term root, we're going to put x, x, x. Then we're going to put 4, 4, 4. Don't forget to square this term, and then it's sum. Okay, we need to follow that sign. It's sum, so we make this sum. This is going to be minus, this one's always plus. The squares are always plus. Now we simplify. So we have 3 out in front, x plus 4, x squared minus 4x plus, and then 16. And there is our final answer for this. So make sure if you see an x cubed, okay, be careful. It might be sum or difference of cubes, so factor out anything you can beforehand. And that's it. That's sum of cubes and difference of cubes. Hope you enjoyed this video and hope it helps. Make sure to comment if you want me to do more videos on any other math-related topics. Thanks for watching.